Good day, class. Today we're going to discuss about gas turbine power plants. So we are powering the future of electricity. So today we'll explore how gas turbine power plants turn fuel into the electricity that powers the lives and why this technology still matters in a cleaner, more flexible energy system. So we'll cover with what a gas turbine plant is, its main parts, how the Brighton cycle works, simple versus combined cycle setups, performance, and environmental aspect, the role in the Philippines, also international, and where the technology is headed. So, what is actually a gas turbine plant? So, a gas turbine plant is a type of a thermal power facility. Uh, that burns fuel most often is a natural gas in order to produce high pressure, high temperature gases. These gases spin a turbine connected to a generator, creating electricity. So globally, gas turbines generate nearly a quarter of the world's electricity, showing just how central they are to the modern energy system. So the core components of a turbine power plant, we have the compressor, so which is the lungs of the gas turbine power plant. So the compressing air up to 30 times atmospheric pressure. So the combustion chamber also, or the engine, where the fuel ignites with compressed air reaching up to 2,300 degrees Fahrenheit or 1,200 degrees Celsius. And also the muscle, which is the turbine, so which is as hot gases expand through blades, it is spinning the shaft that drives both compressor and a generator. So how it works? So the Brighton cycle in action. So the gas turbine actually runs on a Brighton cycle on a constant pressure loop. So you have the compression, which air is compressed. And then you have there the combustion where the fuel is injected and burned, producing hot gases. And you have there the expansion, which gases expand through the turbine. And exhaust when gas exit or are captured in a heat recovery steam generator for combined cycle usage. So, simple cycle versus combined cycle. So in simple cycle, 35 to 40% efficiency. It has lower cost, quick start, used for peaking demand. On the other hand, the combined cycle, the steam turbine reaching up to 60% efficiency. This is best used for base load power. So, these are the example, no, for of a simple versus the combined cycle. So, uh, the performance of combined cycle is firing up to 2,600 degrees Celsius Fahrenheit, peak efficiency, 60%. Sorry, the efficiency performance highlights of modern gas turbines, no? So it has a firing temperature up to 2,600 degrees Fahrenheit or 1,260 degrees Celsius. So the peak efficiency of a gas turbine plant is 60% in a combined cycle mode. So the power output uh, from 34 megawatts to over 570 megawatts per turbine. So, the environmental impact and fuel flexibility of a gas turbine power plant is compared to coal, of course. Gas turbine emits lesser carbon dioxide per kilowatt hours. They're also fuel flexible, meaning able to run on natural gases, LNG, hydrogen blends, biodiesel, or syngas. So they also ramp up quickly, making them excellent partners for balancing renewables like wind and solar. Uh, in the real world application, in the world is Colorado Springs. So in Colorado Springs, USA, coal plants were retired and replaced with six 30 megawatt dual fuel aeroderivative turbines. These cut emissions, improve flexibility, and provide reliable renewable backup. So it is a model of how gas turbines can support clean energy transition worldwide. Um, so while in the Philippines, the Philippines depends on gas-fired combined cycle plants, especially in Batangas. So together in Malampaya, fed plants provide around 2,000 megawatts of capacity, and the gas contributes about 17 to 19% of the national power mix. So the key plants in the Philippines is we have the Ilihan, which is 1,200 megawatts, the largest, which is using gas with oil backup. We have Santa Rita and San Lorenzo, major gen owned plants. We have San Gabriel, 414 megawatts, modern and efficient. Upgraded for lower stable to 191 megawatts. So Avion, we have 97 megawatts, certified to run on 100% LNG gas as well as the natural gases. So we have the Millennium plant, 100 megawatts, Navotas for peaking power. So the role in the power mix, the gas acts as a transition fuel, especially after the 2020 coal moratorium of uh, taking out the coal, no? So as Malampaya reserves also decline, expected by 2027, LNG imports are stepping up already. So LNG terminals are being built to stabilize supply, and most plants are already certified to run fully in LNG. So the challenges and outlook of gas turbine power plant in the Philippines is that, of course, the challenge will be the depletion of Malampaya, which causes the cost of imported LNG and environmental concerns in Batangas Bay. So the new wells and at Camago and Malampaya East are expected to start producing by 2026 to extend the supply. So, but under the Philippine Energy Plan, gas capacity could expand 5 to 7 times by 2050. So it alongside a rapid growth in renewables. So where is the future of the gas turbine power plant? So, uh, hydrogen readiness. So, the future turbines are aiming for 100% hydrogen gases. So, efficiency gains also pushing beyond 60%, more than 60%. Then, of course, the balancing role or ensuring reliability as renewable dominate grids. So, uh, so to the gas turbine power plants combined with speed, flexibility, and efficiency, uh, it helps. The importance of the turbine power plant is first is you have energy security. So it provides stable base load and peaking capacity, critical in the countries like us, the Philippines, where Malampaya and LNG supply balance the grid. Next one is flexibility. Also, like diesel, it can ramp up or down quickly, ideal for supporting intermittent renewables like wind and solar. So also suitable for simple cycle, which is used for peaking, and combined cycle used for base load. And then efficiency. Combined cycle turbines achieve efficiency up to 60%, making them among the most efficient fossil fuel technologies. Of course, it is cleaner than coal. It emits 50 to 60% less carbon dioxide per kilowatt compared with coal. It also produces less sulfur dioxide, nitrogen oxides, particulate matter. Of course, the fuel flexibility and future readiness of gas turbine power plants, sorry, can operate on natural gases, LNG, syngas, biodiesel, and hydrogen blends. So many are being upgraded for 100% uh, hydrogen readiness. So of course, it contributes economically. It supports industries, households, and commercial demand with reliable power. So investment in LNG and gas plant create jobs and infrastructure. And of course, it transitional role, it acts as a bridge technology during shift from coal to renewable energy, and it also provide reliable backup with renewable capacity expand. So to sum up, gas turbine are really a good source in especially in speed, flexibility, and efficiency. So in the Philippines, they are vital for energy security, especially as the Malampaya declines and energy takes over. So globally, the future is moving toward LNG, hydrogen-ready turbines, and even ever higher efficiencies, making them as a key players in clean energy transition. So with renewable integration and cleaner fuel, gas turbines will remain a cornerstone of power system of the future. Okay, so we solve. So the first problem: what is the thermal efficiency of an air standard Brighton cycle if the pressure ratio is 10? So from the formula, so we have E is equals to 1 minus 1 over RP raised to K minus 1 all over K. So the K we will use the standard one, which is 1.4. So the compression ratio 1 minus 1 over, we have pressure ratio, which is 10 raised to 1.4 minus 1 all over 1.4. So the efficiency, you just calculate, I think it would be 0. Sorry, I'll just share. Okay, sorry. So I'll just write again. So what is the thermal efficiency of an air standard Brighton cycle if the pressure ratio is 10? So the compression ratio or the thermal efficiency formula is E is equals to 1 minus 1 over RP raised to K minus 1 over K. So the K would be 1.4. So just substitute it 1 minus 1 over 10 raised to 1.4 minus 1 over 1.4, which is according to my calculator, it's sorry, 0.4821 or 48.21%. Okay, so next. So in an air standard Brighton cycle, the compressor receives air at 101.325 kilopascal and 21 degrees Celsius, and it leaves 600 kilopascal at the rate of 4 kilograms per second. So determine the turbine work if the temperature of the air entering the turbine is 1000 degrees Celsius. So from the formula, we have work turbine equals to MCP delta T. So MCP delta T T3 minus T4. So solving for T4, we will use the formula T4 over T3 equals to P4 over P3 raised to K minus 1 over K. So we have looking for T4. So you have T3, which is 1000 degrees Celsius. So make it absolute temperature. So T4 over 1000 plus 273 equals to 101.325 all over 600 megapascal. Sorry, 600 kilopascal. 600 kilopascal. So we have the formula, sorry, the constant of 1.4 minus 1 over 1.4. So T4, that would be 765.83 degree Kelvin. Or T4 will be 492.83 degrees Celsius. So thus, our work of the turbine would be equals to 4 times 1 multiplied by 1000 minus 492.83. The work of the turbine is equals to 2028 or 2028 kilowatts. Okay, sorry. Okay, next. So air enters a turbojet engine at 200 meters per second at a rate of 20 kilograms per second and exits at 800 meters per second relative to the aircraft. So what is the thrust developed by the engine? So you have F equals to mv 2 minus v1. So m is 20 kilograms per second. V is, we have 800, 200. So 800 minus 200. So F is equals to 12,000 Newton, or the F thrust would be F is equals to 12 kilo Newton. Okay, so that is examples for the solution or problem solving for gas turbine power plant. So that would be all. Thank you.